So here we are back at our Linux machine. I'm just going to launch Metasploit. And what I'm then going to do is just go back to a separate window where we can start to utilize some of the other commands. Now, one of the first commands that we want to utilize is something called rping. Now, when we look at rping, if we just type it, this gives us some usage. It gives us a host IP, an interface, and what type of MAC address is, and the count of packets that we wish to send. So what I'm able to do is use rping, and I can pick an IP address. So let's pick one of the IP addresses that's on my network, and I'm going to craft 5 specific packets. So I'll send these, it goes and hits my machine, and it should stop after 5 packets, and then comes back and tells me that the responses were great. So this is just like running a ping response, except we're using an ARP command to go across and check that that machine is still alive. Now, we could use something different. We could just target that one specific machine to keep it going endlessly. But really, this is the first kind of command that you would want to use to check the existence of targets. Once you have a set of IP addresses, you can then start going through the list and sending these requests. Now, that's all good and well, but actually, if we want to start crafting or scanning across ranges, then we're probably going to utilize something called fping. Fping is a command that will allow us to pass a set of IP addresses or a specific IP address. So if I just type fping, and I'm going to pass a couple of parameters here, I'm going to send 5 packets, and we'll use that same IP address again. Fping will then go ahead and send 5 requests to that machine, but just return a single response. This will give me it did 5 out of 5, and we didn't lose anything. Now, if I'd picked an IP address that was non-existent, I would have got 100% loss at that point. So it doesn't give us the output. It just simply says, bang, I've sent 5 values. Now, what about if we wanted to actually do a whole IP range, for example? So I'm going to go ahead and do the same thing. I'm going to send 1 packet this time, and then I'm going to use the G command and pass it a complete range. Say .1. Let's start at 70, and let's go to 100. Now, what this will do is exactly the same, and here we go. We can see that the responses have come back, and you can see that these ones here on these specific IP addresses on the 80 range, they came back with 0% loss, which means that those machines are alive. But it also means that these ones that have 100% loss, that they're not valid. There's a couple of other ones that have come through. So this is a quick way to be able to say, you know what, I'm going to scan the entire subnet, and I'm going to find the targets that might exist there. So let's just clear that back out. Now, once we have those list of IP addresses, then what we need to do is start to interrogate those machines. And that's where hping 3 comes into play. So for example, we've gone through the process, we've found one of those IP addresses. So I'm going to choose that 192.168.1.70 address. And what I'm going to do is I'm just going to send a packet to that IP address. And it instantly goes in, and I told it to just send a packet to it, and it's crafted it as an ICMP packet. Just a single response. Bang, there we go. Now, what about if I wanted to kind of trace route how it was getting to things? So I can use the same command, hping 3. I can then try trace route. And then we're going to send to that same IP address. So as you can see, we're going to see some bouncing going backwards and forwards. It's gone out of Ethernet 0. It went out to the specific address. It's gone backwards and forwards, and I've told it to basically just endlessly send IP addresses as it's bouncing backwards and forwards using ICMP to perform the trace route to find that information. So let's just clear that one out again. Now I can change the syntax a little bit differently. Let's say that that IP address that I'm connecting to, I want to know if a specific port is available. So what I can then do is I can say, well, hping 3 again, And this time I'm going to tell you to send a SYN packet, because that's the only way I can find out if a port is available. You can't use an ICMP or a ping to get to a port. So I'm going to use a SYN packet. And what I'm going to do is check and say, I want to see if port 80, obviously HTTP, is available. I want you to send it as if it came from port 4444, and then the IP address that I want to send that to. So this is now going to go and interrogate this IP address, look for a specific port, and when that machine looks at it, it's going to say, oh, hey, you've just come from a different random IP address, a different port, and it'll give me a response. So this has now gone ahead to that machine. It's now interrogating it, looking for that specific port. Now notice that no response comes back, and that's because that port is not open. If I just go back and retype that, and let's do that as 445, notice I now get a response back, an ACK response, because I happen to know that port 445, because this is a domain controller, is actually available. So we can instantly tell that when we send a packet request out, if there's no response, then the port is not available. But if I get an RST response back, then that's available. So it's actually a nice way to check the existence of ports. Now what we can do is, what about if ping is blocked? Because of course in some environments ping is blocked to the machines. So how do you kind of go ahead and try to see if something is available when ping is blocked? And that's where, let me just clear this. That's where I can use hping3 again. And this time what I can do is do an ACK scan. So I'm going to do one packet, and I'm going to use port 80 again. I'll tell it we're coming from the same port that we did the last time. And what I'll then do is use the same IP address. So this is going to go, looks very similar to the syntax we used before, but what this one's going to do is this one's going to go ahead and use a ACK scan instead of a ping to the port for that specific IP address. Now, of course, once again, we get a response back. It just comes back and says, hey, there's not really anything that's come back. Port 80 isn't open. There's 100% packet loss. Now notice that it didn't ping it. It just came back and sent a request and said, are you there? And it came back and said, nope. So one thing to remember is that sometimes, depending on the network infrastructure, an ACK scan can get blocked. Most firewalls will do this now. But in some environments, you'll be able to do exactly the same thing, send it to that packet, and you'll get an actual response. So let's just clear that down. Okay. Now, when we start to do major scans, then this is where we're going to utilize something called NMAP. And typing NMAP into the console will bring you a list of parameters as long as your arm. So we're not going to go through all of those. So what I'm going to do instead is type NMAP. And what I want to do is basically just do an ARP scan. An ARP scan to a full subnet, or at least a subset of the subnet. So I'm going to go in and use the parameters PR and SN 70, and then I'm going to stretch that out to, let's do that to 100. Now this will kick off NMAP. NMAP then starts at the 70 address and starts to go across the entire network. And there we go. So as you can see, it came back pretty quickly. If I scroll up and down, we can see that the host is up, the host is up. It brings back the machines that are available. Notice 70, there's no 71, 72, 73, 74, 75, no 76 or 77. So what it's actually done is it's narrowed down the list of IP addresses that are available. So of course, now we have that specific set. We could actually do that differently. So if I just press clear again, I can use NMAP. I used an ARP scan last time, but what I can actually do is use ping to do the response instead. So I'm going to use similar syntax. I'm going to use SN and then PE 192.168.1.70 all the way to 100, and then click enter. This time around, we're not using an ACK scan, we're using a ping response. So this is going to send a packet that's going to go across and ping, and there we come back with the results again. So it looks very similar. You have two different ways of doing it. The difference between using an ACK and a ping is really the amount of noise that you want to make on the network. That if you want to make lots of noise, then send ping packets across the network, or start flooding the network with traffic trying to find the machines. Now, what you can do is you can actually target and say, well, what about if I wanted to perform the same thing? So we'll go with a standard scan, but this time I want to look for a specific port, and I'm going to use a UDP port of 53 on the subnet. So we'll do that same range again, 70 to 100, but this time when I use NMAP, it's not going to just find the machines that are alive, it's going to go and find the machines that have port 53 enabled. So we'll go ahead and leave that scan in. And there we have our information that's come back, and you'll see that lots of the machines have come back saying that 53 is open. Now if we clear that and we want to change the target slightly, let's go with that 445. So we'll go with UDP 445. And as you can see, you can change the syntax. You can go through and say, hey, I want to have this one, and it will say the host is available. If we go back, we can change this to any kind of port that we want to. Now what's lucky is all my machines are Windows machines, so they have some of these available anyway. So we're able to go through and scan by a specific port across a range. Now that's good and well. Those tools that I've showed you, which is rping, fping, hping3, and nmap, really are just tools to kind of use really before you get into Metasploit. So let's just minimize and go back to my Metasploit window, which will be here, and we'll full screen this. Now what we can do is, remember, let me just clear this so you can see it, and type search, and this time we'll type the word search scanner. Now in the last modules we did search exploits, search payloads, search auxiliary. What we're doing now is specifically looking for scanners which reside in the auxiliary container. And so it comes back with a whole list. You'll see we have an ARP scanner, we have a whole bunch of Windows login scanners, but what we can do is we could use a specific scanner. So I could say use auxiliary, I can then say scanner, and we'll do an SMB scanner, and we'll use SMB enum shares. So what this one's going to do, this allows me to connect and see shares. So if I do show options, which was a command that we hadn't looked at yet, when we have the ability to use an exploit or an auxiliary scanner or a payload, we have options available to us. So if I click show options, you'll see I have some settings, one of which is rhosts. Rhost is the target address, the machine that we want to get to. Then it's going to ask us for some SMB credentials, which we'll just use an account on the domain that I have right now. And then we have some other parameters that will allow us to show files, spider shares, whatever it would be. Now, in order for us to set these values, we choose set. I'm going to choose set rhosts. We'll use that same IP address that we used before. So that now sets the rhost, which is the target machine, to that one. I'm going to set the domain to my Conesis Labs, which is the name of my domain. I'm going to set my SMB user to Loki, which is a user on the system. And then I'm going to set the password to the most secure password on the planet, pass@word1. So if I just now do show options again, you can see that we've completed those values. I have an rhost, I have a domain, I have a password, a username, and then some other parameters. And I'm going to leave everything else as it is. And then I'm simply going to type run. And this comes back and says the login failed. We didn't quite get a connection because it tried to go around on port 139, but then it hit 445 and then iterated through. So I was able to use a Metasploit scanner to hit my Windows machine using the credentials that I have, and it was able to list me the shares on that machine. And that's quite useful because that means that, and as I'm looking at target machines and trying to look for exploits, that if I can enumerate shares on a machine and it comes back and says, hey, it's Windows 2012 R2, now I need to look for an exploit of some description so that I'm able to utilize those shares that are available. What we'll now do is clear this out, and we'll actually flick over to the other console window. We'll remove the values from here that we had last time, and then we'll flick over to Wireshark. And obviously Wireshark is a network analyzing tool, but this allows us to set some specific values and then we can log that information. So for example, you choose the specific port that you want to go out of. I'm going to choose start, and this is going to go ahead and capture all of my traffic. But what I can actually do is do some filtering that says Ethernet type. And actually what I want to do is I want to use a specific number that's going to look for ARP packets. So you can see that we've got an ARP request from here. So we have some requests going backwards and forwards. Who is that address? Who is that address? So now Wireshark is configured to just look for ARP requests. So if we flick back to our console here and we need to initiate an ARP request, what we can do is we can utilize one of the tools before. So we could use rping, and I'm just going to utilize one of the servers. So we'll do an rping, and we'll go back to here. And as you can see, instantly we have ARP packets going backwards and forwards. So we can see the broadcast is coming. We can see the question, who is 192.168.1.70, and tell me who that is, and 45 is me. So obviously we'll stop that going because that's going to send quite a few packets. So let me just clear that and go back. So you can see right here, the packets are gone backwards and forwards, and it says, who is it? Tell me. And then 192.168.1.70 returns the MAC address. So we can instantly target it to ARP values. Now what we can also do is actually, if I just remove that, it'll go back to checking everything. But I could choose UDP. I could then say, actually, what I'm looking for is anything that's UDP with a specific source IP address, which in this instance would be my IP address. So if my IP address as listed in here is 45, then anything that I send out which is a UDP request with an IP source address of me will get flagged up. Now I could also do the same thing. I could say TCP and do the same thing. Or what I could do is change it even further and choose destination, and actually the destination is 70. So I can say anytime a TCP packet is initiated and the destination is that, show it. Or what I could do is just remove and just say IP destination is this value, and anything that's leaving and going to that machine. So if I go back to here and I run my rping command, then notice the rping commands don't show up. So let's change the syntax that we're sending. So if I do ping and do a ping response, you'll see that now my ping responses come back. So be careful that the destination is only really valid depending on the types of content or the packets that you're sending. So we're able to clearly see the traffic going backwards and forwards. Let me kill my ping command and let me just clear that. So if we just clear those values down, you can see that it goes back to listing all of the values that are there. Now what's useful is the ability to go in and try various commands. So if I go through and do a SYN, or yes, a SYN one that we did earlier with hping3, I can actually go in and say, actually I'm looking for port, let's do 443 because we know that responded. And my source port is 444 with my IP address of 170. And I can send that response, and then when I go over to here, you'll be able to see the traffic that's going backwards and forwards. So notice we can see it going backwards and forwards. Let me just stop that for a second. You can see that my values are going backwards and forwards. So this is the destination is 70 from me. I'm sending a TCP, a Microsoft one. It's going backwards and forwards, and you can see it's sending the values. And you can see it's the port 445. So coming to understand how to use Wireshark. Now, we're not going to spend lots of time understanding Wireshark, but it's important to know that when you run the various commands, whether it's auxiliary scanners in Metasploit or whether it's the specific tools, that the response and the implications on the traffic and what you get back are very important.